This series of videos is going to cover special cases where we need to do a little bit of extra work to solve the equations. In this first one it says a multi-step equation given in fractional form. So here we have x plus 40 over 7 equals 4. So we have it in fractional form. Our goal is going to be the same. We're still going to isolate the variable, but first we have to clear the fraction. And to clear the fraction, we're going to multiply both sides by the denominator. Then we can apply our additive inverse, and then we can apply our multiplicative inverse. So I'm going to take a couple of seconds for you guys to pause the video and to write these steps down. Now that you've gotten the steps written down, let's look at how to break the problem down. First, we're going to rewrite the equation down below here, or off to the side wherever you have room. We're going to say 4 equals x plus 40 over 7. And to clear the fraction, it says multiply both sides by the denominator. So what we're going to do is we're going to say times 7. And over here we're going to say times 7. And both sides means that we once again split our equation in half. And so what this does here is it takes the 7 out of the denominator because 7 over 1 times anything over 7 is going to cancel itself out. And then over here we'll multiply. So let's rewrite again here. Okay, so now we'll have 28 equals x plus 40. And this is a pretty simple one because we don't have a multiplicative inverse because it's just 1x. And so we cleared our fraction. The next step is going to be to apply the additive inverse. Okay, so here applying the additive inverse means we're going to add negative 40 to both sides. And if you guys have been watching the videos closely, you know we keep saying add negative, and I keep changing it to just subtraction. Once we get really good at these, we'll notice that that's what we'll be able to do. But here we have 28 plus negative 40. So let's rewrite this with the negative 40 on top. So we'll have negative 40 plus 28. Okay, now we have subtraction because our signs are different. Different signs mean subtract. And so what we can do is we can borrow, make that 10, and so we'll end up with 12, and it's negative up here, so it'll be negative 12 equals x. The next example, as you see, is a fairly similar problem. 3x plus 17 over 2 equals 4. We're going to perform the same steps. Our goal is to isolate the variable, clear the fraction, and then apply the additive inverse, and then apply the multiplicative inverse. And so far, we have rewritten the equation, cleared the fraction, and then rewrote it again. I want you guys to go ahead and pause and write down the work here that you've seen. The next step I've performed is the additive inverse. I added the opposite value of my constant to get 0 here, which left me 3x, and then 8 plus negative 17 equals negative 9. And here's that work right here. The last step we're going to perform, we can perform together. It's the multiplicative inverse, which means we're going to multiply by the flip. The flip of 3 over x is 1 over 3. And so we will get these to cancel out, so we'll be left with x equals negative 9 times 1 over 3. So we'll end up with x equals negative 9 over 3, which equals negative 3. And that is solving fractions, or solving equations in fraction form.